Hello everyone, in this video we're gonna do a video tutorial on introduction to Python. Now what I'm going to teach you will work if no matter what version of Python you're going to use, because there'll be just minor variations, but the whole concept, founding concept of Python will remain the same. I'm using Python 3.1 for right now, but whatever version that you're going to use, it will work exactly the same. All right, what is Python? And so Python is a very high-level programming language that is general purpose and is known for its simplicity, readability, and versatility. It uses an easy-to-understand syntax that makes it beginner-friendly, and while it is also very powerful in professional settings. It emphasizes its code on readability. It's easy to read. It's more or less like basic English. It allows developers to write logical and concise code. Python was introduced by a man called Guido van Rossum in 1991, and since then it has been developed to be applicable in many settings such as web development, software development, database access, game development, desktop applications, education, network programming, cybersecurity, and many other areas. So why is Python so popular? Python is popular because it is easy to learn. There's a ton of community support. It is cross-platform, which means it can be run on Linux, Windows, or Mac, or many other platforms, and also for the rich ecosystem. And now, since I've just did a quick introduction to Python, let's get started on our first print statement. All right, I am using Jupyter Notebook here. You might be using a different IDE. You might be using PyCharm. I always recommend people to use PyCharm, but you can also use Visual Studio Code or many other IDEs out there that you can use to write your Python code. I'm using Jupyter Notebook. I just love it, and that's why I'm using it. There's no other reason other than just I love it. All right, let's do our print statement. All right, so right now we are writing our first code. If you just want to print something out, you use the keyword print or the method print. You can use single strings, hello world, and when you run it, it's going to print hello world. So you can use the single quotes or double quotes. So double. Okay, let me do it this way. Hello world, it will simply work the same. All right, so these are words, we call them string in Python, but we can also print numbers. For example, I can just say print 32 and run it. It's going to print 32. This is a number, this is a word. You can also print multiple items using commas. Commas in Python, they add space between items. For example, print, the answer is 45. Or run it, the answer is 45. Now, on the print statement, there's also what we call special characters. Let's explore them. Print hello world. Now, if you do a backslash and an N, let's see what's going to happen. I'm going to print it. It's going to kind of stack them on. This is a symbol for a new line. You're instructing Python to go to the next line. We also have another symbol that adds a tab space. So for example, print, let's do a hello world again. Then we do our backslash again and a T. When I run it, it adds a tab between the two, between the two items that you specify in your code. Let's do another backslash. All right. Alrighty. If I run this one, it's going to print a backslash. So if you want to print a backslash, it has to be double. Let's also talk about escape characters. So let's say backslash Python, another backslash, then also backslash. So let's see what's happening here. Let's see what's happening here. Alrighty. So if I run this one, so now if I want to print the semicolons, I have to wrap them within another one. So this one and this one is going to allow me to print the semicolons. And if I want to use a semicolon, this one, I have to use the backslash to be able to print that. All right. Let's talk about variables. Now for variables, so variables are containers that we use to store data. So there are different types of data out there. We have string data, we have numbers, we have booleans, we have floats, we have list tuples, you name them. So variables, we use them to store data. So for example, I can use a variable called name to store the name. So when I say print name, it will print anything that is contained in the variable name. Sterling arrays. So again, we can say age is equals to print age is going to print anything that is stored in the variable age. All right. So we have name and age. Name is Sterling arrays. Age is equals to 45. Now I can combine variables with text. For example, I can say now print all right. So yeah, look what's happening here. I'm saying this is a string, and I'm referencing this name. Age, I'm referencing this variable age. So I'm going to print this one out. Sterling arrays age 45. So you can now combine variables within one print statement to produce whatever you want your code to do. Let's do string concatenation. So for example, here, if I say print, empty string plus world, I want it also to be a string. Let's see what's going to happen. All right. What if I remove this empty string? What's going to happen? It's going to kind of combine the two. Alrighty. I can also do print hello times 5. Let's see what's going to happen. Hello, 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 hello by 5. All right. So you can use this to do some funny things. For example, you can do this. You can print 5 stars. You can do whatever you want. You can actually do patterns. All right. Let's do string formatting. So suppose I have two variables. One is name, another one is age. Name is equal to Alice, age is equal to 25. I can use this formatted string to be able to combine the two. So when I run name is equal to Alice, age is equal to 25. So we can also do what we call positional formatting. So for example, so right now I've got name and age, and I can also do something like this. Curly brackets, comma, age, curly brackets. Then out of the course, I can do dot format, then name and age. So if I run this one, look what's going to happen. So this is kind of a placeholder for name and age. Name is equal to Alice, age is equal to 45. So it gives you like the opportunity to format your data the way you want, your print statement the way you want it. So that is using the dot format. And let's also do the positional formatting. So I have coordinates here is typically the same here. So coordinates, I assign an empty, I would say an empty variable for now, but kind of a placeholder that will be, Python will be smart enough to assign 10 and 20 in here. So when I run it, coordinates is equal to 10 and 20. We can also do, since we're here, let's do keywords. So you'll find if you are using PyCharm, PyCharm is very good at this to give you those keywords argument. But let's take a look. So name, then you use your curly brackets, age, again my curly brackets, and I say a out of the thingy, and use dot format, and say n is equals to name, or actually I can say name is equals to James, and a is equals to whatever age that I want to put. So when I run this one, it's gonna see the keywords, replace the keywords N for James, A for 20. All right, that's a lot. Let's keep on going. We can use the custom separators using the print statement. So let's say I have print apple, banana, cherry, separate by a comma. All right, so if I run this one, they all be separated by a comma. So it's again, you can do a odd again sep is equals to you do your you can specify whatever you want to specify separate by and run it. So it's gonna separate them by whatever you specify. Let's say if I want to do something like this, whatever you assign, it's gonna do the same thing. All right. You can also use the print statement to print the data structures. We'll come to that later, but let me just introduce the concept. So we have what we call lists in Python. So my list is equals to, we use these square brackets. So I can now just say print my list. It's going to print out the list that I have. You can do the same for dictionaries, for tuples, for anything. There's also what we call multi-line printing. So let's say print, you use three, one, there you go. This is multi. So if you want to print your string in 3 lines or any other number other than one, that's you use those three. You open it, your print statement with three quotes here. You can also do calculations. So let's say print 2 plus 6. You can do print 2 times 6 print 2 minus 1. So to give you your answers here. So I think I've exhausted most of the things that you do with the print statement. Now I want you to do an exercise. So in this exercise, I want you to write a program write a program to print a short introductory about yourself using variables to store your name, your age, and your favorite hobby. Print and format the output using either F strings or format. You can pause the video here and go ahead and work on this problem. If you are stuck in any way, go back to all the tutorial and try to see how best you can do that. And I'll go ahead and show you how I would solve this problem. All right, so write a program that will introduce yourself. So you need maybe your name, that's a variable number one, then maybe last name, another variable, maybe age, another variable, then hobby, another variable. All right, so print, we can use the formatted string. So we said F, then we use this one. So my name is name. I am So I'm going to print this one out. This is how I would solve that problem. So let's go ahead and move to the other section of this tutorial. So in this section of the course, we're gonna talk about variables and data types. Of course, I've introduced variables and data types in the previous video, but this is more like a section dedicated for them. Alrighty. So in Python, we have, I would say, 5 main data types. There are plenty, but for the introduction part of it, let's just say we have integers, we have floats, strings, and bullets. So let's go ahead and just do first with the string. Name is equals to, let's say, Alice in this example. So if I do print type name, it will tell me what is the type of data stored in name. So name is a string. Let's say I say age is equals to 50. Type age integer. I'm just gonna copy this one and say height is equals to 6.2. Then I want to change here. It should be a float. So a float is a number with a comma. Now let's do its student is equals to true. Print type. Alrighty. It's a Boolean. All right. So these are your basic types of data, but we can change it. So for example, let's say we call it type conversion. We can change a number from a string to an integer, depending on a use case. So you can change it. Let's say, for example, is equals to 10. Now, if I check the type of this one, you might have guessed it already. It's a string. But if I check the type here, it's a string, right? So I can change it now and say new name or new name for new number is equals to integer. So print new num. And also I want to see the type of new num, type new num. Perfect. It's now an integer. Why? Because we kind of casted it with this int for integer. So we said although we have got a string, we want it to be converted to an integer. So when we new num is now a 10 integer, and to the type will become an integer. So you can do the same for float. Again, it's going to change. And you can also do a Boolean. You can do the same. Now, this brings the concept of this is where Python is very gets all the points for me. It's dynamically typed. You don't have to declare the type of the variable when you write a variable. You can just convert your variable types as you go. So, for example, let me say, all right. So x is equals to 10 is an integer. Hello x is equals to hello is a string and a float. You don't have to pre-declare them, but as you type them, you kind of assign the types as you go. So for your exercise, I want you to create a program to calculate the area of a rectangle using variables, or convert temperatures between Celsius or Fahrenheit. You can stop here and work on this problem. Otherwise, I'll go ahead and give a solution. All right, I hope you got it right. So create a program that calculates the area of a rectangle. And change this one to Markdown and run it. All right, so for area of a rectangle, we need the length is equals to, let's say, 12. Width is equals to 5. Area is equals to length times width. Print area. When I run it, it's going to give me area. And you can format it using our formatted strings like I showed you before. And I can actually do that real quick here. Area of the rectangle is, then I'll use my curly brackets and do area here. Oh yes, I can fix this one. Oh yes, I just need to close with the bracket here. And when I run it, it's going to give me the perfect one. All right, let's move on to the next session. Thank you for watching. So far, our programs have been printing out to the terminal, but in real world, you want a product that will interact with the user. So it might ask them their name, it might ask them their age, whatever it is that it might ask them. You'd want the users to input something, then you can digest or ingest what they input and manipulate with, or interact with your program. So in this section, we are going to learn about user input. So you're going to understand how to take input from the user and interact with it dynamically. You can also gonna gather user data and also gonna learn how to handle the input types. So let's go ahead and get started. So let's say, for example, name is equals to, we use the input method. What is your name? All right. So it's going to ask the user, what is your name? John. So enter. It's going to print out name, which is John. Again, let's do another one. Input. Enter your age. Print age. All right. So I want you to notice, or maybe let me ask you a question. What is the type, or the data type of age here? We have a 10. All right. For those that say it's a number, that's not quite right. The correct answer is a string. So let's do it. Let's check it out and see what is the type here. So we're gonna see what's the type of edge, data type. All right, let me just give a number here. It's a string. Why? Because by default, all the results of an input function, they are always a string. So this brings us to the concept of handling input. So depending on the data that you're looking for, you can format it in such a way that it comes in a data type that you are looking for. For example, right here, we are looking for a number. So we need to make sure that this one, edge, will remain a number. So how do we do that? We simply do casting. So we wrap everything in the integer. So now when we say we run this code cell, what's your age? 35, enter it, is now an integer. So that's basically the input function. And you can write a program that allows the users to interact with the program. They can, whatever the input, whatever the program asks them, they input it and your program will process it. And you have a dynamic, more interactive program. So for an exercise, I want you to write an exercise, ask the user for their name, their age, then print a personalized greeting, or build a simple calculator that takes two numbers in an operator as an input. If you can pause the video here and try to work through that problem. This is the exercise. Ask the user their input, the input of their name, age, then print out a personalized greeting, or build a simple calculator that takes two numbers in an operator as an input. All right, and I am going to go ahead and provide a solution to this problem. All righty. All right, so name, input, now we need to cast it into in an integer. Then print. Now this is where you can use the string formatting. Hello. Then we need to use name here. I can actually do this at this specific edge. Then if I run this one, it's going to ask enter name, John, edge 56. Hello, John. Glad you are learning Python at 56. So let's move on to the next section of the course. All right. In this section of the tutorial, we're going to look at conditional statements. These statements allows our program to make decisions. So what you're going to learn, you're going to learn if statements, else if, and else if, and else statements. These are very powerful in evaluating your code and to make decisions based on your code. All right, so let's get started. We will start with a variable. Let's say age is equals to 20. Now, here's how we do it. If age is less than, let's say, 18, print you are a minor. So I want you to notice that the moment I do an if statement and press enter, Python automatically assign an empty space here, a tab here. It's very important because it shows that this one will be executed under this if statement. All right, so we use else if we have any other condition, we use else if. So we write it as elif age is equal to 18 semicolon. I wanted to print something else. Print or you just became an adult. Perfect. Anything else other than this one, I wanted to print you are an adult. All right. Actually, okay. So because age is equal to 20, what if I say 16 here? You are a minor because the code evaluates and say, is age greater than 18? Yes, then you're a minor. All right. What if I say 76? You're an adult. What if I say 18? So you just became an adult. So you can now take it from here and ask your users, say input, enter your age. Right. If I run this one, oh, okay, I can show you that. So run, enter age, and I'll say 20. It's going to give me an error because we said input always gives you, it's going to give me a type error. We're gonna have a video for how to handle errors, but it's gonna give me a type error because the input function always gives you a string. So we are trying to do mathematical manipulations on a string. That will not work. So again, you need to use or you need to cast it in an integer, and now your code is gonna work. And run it, and I'll just say 18. Then it's gonna work as expected. All right, so that's basically that. Or maybe since we're here, let's you also do what we call comparison and logical operators. So you have seen here, I have used double equals. It means that both sides of the equal sign need to be the same. Age is equal to 18. So there are other things like, so this is equal to, this is not equal to, and these are greater than, less than, greater than or equal to, less than or equal to. Then we also have and, or, and not. So I will just convert this one to a markdown, and I can actually delete it. Don't necessarily need it, but I'll showcase how this can apply. So let's say age is equals to 25. So if age is greater than or equal to 18, and that keyword, and age is less than 60, I want it to print, okay, because I changed this one to markdown, that's why. Let me start one more time so that you can see. So age is equals to 25. So when I write if it's a key word in Python, Python is smart enough to assign a different color. So that's why if is given a different color here, even equals is given a different color. So if age is greater than or equal to, I'll say 18, and age is less than 60, your semicolons, print, you are eligible to work. All right, so we're gonna run this code. This person is 25, so they're eligible to work. What if this person is 16? This person, or then you can add else if less than 18, or else whatever condition that you wanna put in there. All right, so for exercise, write a program that asks the user to input I can copy it right here and give it to you. Write a program to determine if a number is positive, negative, or zero. All right, pause the video, work on it, and I'll go ahead and provide the answer. All right, it's basically what we've been teaching before, and we use input. So enter a number, Now you can either assign it as an integer or as also as a float. In this case, let's just do float. Wrap everything in float. So we're gonna check condition. Right, we use these hashtags to write text. This when Python sees this hash, it won't execute anything after it. So if num is greater than 0, semicolon, print the number is positive. Elif num is less than 0, I need to print else print the number is 0. All right. So we want the user to input the number. So I'm going to run this one, enter a number. Let's say 1. The number is positive. I'm going to run again. Let's do 0. Enter. The number is 0. All right. So the code is working as we are expecting. If you want another program, write a program that checks if the user is eligible to vote. So it will check if the user is greater than or equal to 18, then they're eligible to vote. Else, you're not eligible to vote. Thank you. Let's go on to the next section of the course. Hello friends, in this video, we're gonna learn about loops. Now, loops, we use them when we want to perform repetitive tasks. So let's go ahead and jump into it. The previous video, we looked at conditional statement, which start with an if. If a certain condition happens, then this happened. Now, for while loops or for loops, we start with for or while. So for, example now. One moment. All right, let's say I in range. Now, I haven't really introduced the range function up to now, so I'm gonna explain it a little bit. The range method. So what I'm saying is this can be any item here, any whatever you want to say. It's just a variable. So for x in range 1 to 11, so range 1 to 11, we start from 1 all the way to 10. We don't count, we skip the last number. So let's say if it's 15 here, we go all the way to 14. So if I run this one, it will print all the way to 14. All right, so that is basically your for loop. We're going to use that in different programs later, but let's look at while loop. So let's say I is equals to 1. Now we're using while loop while I is less than or equal to 10, your semicolon, print I. If I print it like this, every time I is less than 10, which is 1 is less than 10, yes, print 1. Is 1 less than 10? Yes, print 1. Is 1 less than 10? So it will be a continuous loop. So you'd want to count it by saying I plus or equals to 1. So it will say, is 1 less than 10? Yes. So 1 plus 1, which is 2. Is 2 less than 10? Yes. 2 plus 1. You keep on running all the way up to 10. So you run it, it will go all the way to 10. So let's go ahead and explain things like give a break, pass, and continue. All right. Clear this a little bit. I'm going to delete this one. I'm going to delete this one. Perfect. All right. Let's say, for example, we have a loop that is that we want to break before it finishes. We can use a break. So let's say, for example, I have my initial loop for I in a range 1 to 20, a semicolon. If I node 7 is equals to 0, I'll explain this when later what this is doing. Print. I'm gonna say just print I. When it's done, I want it to break. All right. So what it's doing is any number that is divisible by 7 is, if I is, all right, so this one, it's a remainder. I will explain it in a video specifically for that. But if I would divide it by 7 is equals to 0, then print I, then break also. So when I run this one, so it will check is 1 less than 4. If 1, for any number in the range 0 to 1 to 10, if that number is divided by 0 and there's nothing, there's no remainder, then print that number. That's basically what we do when we are breaking from a while loop. All right, let's do a simple one. Let's say for I in range 1 to 11, if I node 2 is not equal, I explained not equal in a previous video, continue. Then I want it to print I, print I. All right, so I want to, in basically what I'm doing is I'm trying to skip node numbers. So if the number divided by 2 is not equal to 0, continue. I always print I. So let's go 2, 4, 6, 8, 10. So I'm dividing the number by 2. If the answer is not equal to 0, continue. All right, let's do explain again. Pass. Let me just insert a new cell here. Right, for I in range 1 to 6, if I is equals to 5, pass, else print I. So basically, when it's going to look for these numbers in this range, when it's come to 5, don't do anything. So pass, else print I. So it will not print 5. And if I, even if I do like 12 here, still when it comes to 5, it will print 5. It will skip 5. It will pass 5. So basically, that is your loops. The exercise for this one is print numbers from 1 to 10 using both for loop and while loops. Or another one, build a program that calculates the sum of all even numbers between 1 and 100.5. Thank you for watching. See you in the next lecture. Hello friends, in this section of the course, we're going to learn Python functions. Now, our functions are very powerful, and once you learn your conditional statements, your loops and functions, you can begin to write some useful programs that you can apply, of course, not more so in the real world, but that you can apply to solve a lot of computer problems. So what is a function? So a function is a block of reusable code that performs a specific task. Functions, they basically help to make your program more modular, more readable, and more maintainable. So a basic syntax for a function, you have to preface it by def, which is defining it, then your function name, followed by these brackets and a colon, then whatever you want in your function. So this is the basic structure of a function. Let's now write our first simple function. I'll say def greet print hello world. So now I have set up my function and I need to call it greet. And when I print it by code, you have to do 2 lines here, 1, 2, then greet print hello world. So that's a simple function here. And let's do a function with parameters. Now we're going to use our formatted string one more time. Since we specify, we put name here, it's kind of a variable or a parameter, then we have to input. If I run it without anything here, look at what it's gonna say. Missing one positional argument name. So we have to specify the positional argument. Let's say Alice. When I run it now, it says it will execute this block of code, print hello name. What is name? Alice. Hello Alice. Now that's one parameter, but you can go ahead and put several parameters. So let's say DEF, I want a parameter that add numbers. So A and B parameters. And we go, let's say when I just return for now, plus B. And I use my formatted string one more time. Actually, let me just add nums. The sum is 8. So I've just put two parameters here and use the return keyword, and you can also use multiple parameters. And for now, we just gonna end it here on the parameters. But since we're here, we can also do default parameters. So let's say def greet. So now I've assigned a default name for guest as a default for name. Perfect. My formatted string one more time. So now if I call greet without assigning any name, it's gonna just replace, you're gonna just use the default name provided. Hello guest. But if I go ahead and give it a name, it's gonna replace and use the name that you give it. All right. There are other things that we might talk about functions such as local and global. But for now, we're going to end it here, and let's go ahead and move on to the next section. Welcome back. In this section, we are going to learn about data structures. Basically, we are talking about lists, tuples, dictionaries, and sets. You would find most of the time that you're writing your code, you are going to use these data structures to store your data, to manipulate your data. So we are going to start with lists. Perfect. All right. So here's the syntax for creating a basic list. Let's say I want to create a list of fruits. I use the square brackets. Square brackets. We also have mixed lists such as, let me just put it like this. Then we have hello with a number, another text. and I will just add a boolean here, true. So this is also a list. Let's say if I just print type mixed list, it's a list too. Mixed list is a list too. All right, so that's your basic list. You use square brackets and you separate items in the list by a comma. And now back to what you have learned previously, we can use for loops to iterate over this list. You can manipulate the list in multiple ways, but for now, let's go ahead. So let's say I have my fruits here, and just run it for you to be clear. Let's say I want to pull, this is indexing, item on position 0, it will return apple, because when you do indexing, we start from 0. So this will be 0, 1, 2. So if I want to pull banana, I can just say 1 and 2, orange. Perfect. You can also add items to a list. So let's say fruit. If I say fruits.append and say maybe cherry, print fruits, you can see that cherry has been appended to the fruits list. And you can also remove using the remove. Let's say remove banana, print fruits. So fruits will be printed, but without banana. So they are multiple. You have to go to python.org for documentation to see multiple methods and a list. So we have learned append, remove, but there are others like insert, sort. You can do a lot of things. You can slice. You can slice your list. Let's move on to tuples. All right. So tuples and lists, they basically look the same, but the only difference is that you don't use square brackets. So let's say here, copy. Now, instead of square brackets, you use this type of brackets. Print type. All right, I'm gonna print the type of this variable. It's a tuple. All right. So again, a tuple, I want you to know it's an ordered collection. It's immutable, so it cannot be modified after creation. So this is very, very good. Let's say you want to collect data that cannot be modified after it is created. It may be the date of birth or whatever that you want to collect. You can use tuples to store your data, and also in tab, I want you to also to know that tuples allow you to duplicate elements. So this is a string tuple, but you can still create again a integer tuple. All right. So this as a tuple. You can use different methods that are also unique to tuples. Let's say I have a. Let me delete this one. Let's say I have my colors tuple here, and I can now access elements from this tuple. So I can say print colors. Then I want to specify the index position. So when I'm printing this one, it will tell me it will give me back. We said 0, 1, index position 1. So I can do semicolon and 2, and it will take all the way. So this is 0, 1, 2. So it will just return from index position colon 2. And also we can do what we call tuple unpacking. So So right now, let's say A, B, C is equals to colors. We have three items, so A is red, B is green, C is a blue. Right, perfect. So if I say print A, B, C, let's see what's going to happen here. Red, green, blue. This is tuple and packing. I've assigned variables for items in a tuple and they can now be printed out. You can count, you can do indexing, you can do a lot of things with tuples. Let's go ahead and do dictionaries. So dictionaries are an ordered collection of key value pairs. Keys must be unique and immutable. So they can be strings, can be numbers, can be tuples. Values can be of any type. I would say if you're starting, view a dictionary as an actual dictionary, you have a key, which is, let's say, a word, then its meaning. So it's a key and a value, key and a value. That's basically a dictionary. So in it, it's almost the same, but you use different kinds of brackets. You use what we call curly brackets. Let me do it this way. Let's say student is equals to use this type of brackets, curly brackets. So name, the name of the student, I'll say Alice, then comma, age 23, comma, grade, maybe grade A. So print type student. So it's going to be a dictionary, dictionary. All right. So there are methods that are also common operations that are unique to dictionaries. So let's say, for example, let's say print student. Then I'll go square brackets name. It's gonna. I have assigned the. I've requested the key. It's gonna give me the value. So if I had said here age, it's just gonna give me 23. All right. So you can add. You can access values. You can add or update the key value pairs. So you can also remove key value pairs. You can also iterate, and you can also do a lot of things with this. So I'll just show you maybe iteration for key value in student. So it's gonna print your keys and values. Perfect. Um, Dictionaries, I would also, maybe the use case for dictionaries would be if you want to store data such as usernames and password, you can use dictionaries to do that. All right, let's move on to another item called sets. Now, sets are unordered, so they are a collection of unique elements. They are mutable, uh, so such as numbers, strings, and tuples. Let's create our basic set. Unique numbers. Again, we use these curly brackets. All right. Let me for just to show that it has to be a unique element variable. So when I print unique numbers, I want you to notice what's going to happen here. So I've got two fours here, but when it's printing out, it's going to just return 1 4 because, as I said, it has to be unique elements. So the other four will be ignored because it is a duplicate. Alrighty. So let's go ahead and do some common operations. I'll just take this one out, put it one more time. Perfect. So I can add numbers. say 85, then print unique numbers. 5 is going to be added. All right, let's move on to what can we talk about this. So let's say you want to work with you're working with a set and you don't want duplicates. You can maybe convert your list to a set, then work with that. All right. Uh, Data structures are very key. Please master this concept and move on. So for the exercise on this section, I want you to just play around and create your first sets, dictionaries, and tuples, and also go to Python documentation and look for other methods that you can perform on lists, tuples, dictionaries, and sets. Thank you for watching. Let's move on to the next section of the course. So I've been talking a lot about python.org. Check the documents, check the documents. A seasoned programmer will always go back to refer to the documents. It will save you time and energy and a lot of frustration. Anyway, I'm at python.org, and if you want to look at the documentation, this, just let's say a quick overview of this website. It will tell you everything that you need, how to get started, how to download all the docs that we have and the jobs. So if you go on documentation and go on Python docs, you can go on tutorial, and it will guide you step by step on the things that we've discussed, and the things it will go maybe into more deeper analysis of the things that we discussed and that we are not going to cover in this quick tutorial. But please visit this and it will help you. Anyway, you can also take a look at this right here. Jobs, pythonjobs.org. How just see how we South Africa, Ireland, Canada, they are all looking for people who have got some familiarity with Python. So always look at this. It will help you play around with documentation. It will also help you in your day-to-day work as a programmer. Thank you. Let's go to the next section of the course. Now, in reality, in your actual application of Python in your work environment, you'll be working with files. So these files can be various formats such as text files, Excel files, CSV files, and many other PDF files, and many other types of files that you'll be working with. So you must be able to know how to handle files. So in this section, we are going to discuss file handling in Python. So here are the keywords. Use R to read, W to write, append for with A, RB to read the binary mode, and WB to write the binary mode. All right. So right now, if you look back here, I have a file that I've already uploaded, which is called Jupyter, which is called music CSV. If you just drag it and drop it here, it will or hit upload and look in your file explorer and upload the document. But I've already done that, so I'll just close this one. I have a file called music CSV, so we're going to work with that one. All right. Let's say with open, you specify the file that you want to open and the file type. You want to read it as file semicolon, then it will automatically indent for you. Then data is equals to file.read, our read method, then print it out. It's gonna pull that file and read it, and it will give me the what's in that data. So this is age, column for age, column for gender, column for genre. Alrighty, so let's read line by line. So that was just reading the entire file. So you might not need to read everything. You might need to read just line by line. So let's do reading line by line. Again, with open music.csv, specify I'm going to read it. It's fine. Lines is equals to file.read lines. Now we're using the read lines method. Print lines. So the first line is age, gender, and genre. The first line, those are the column names. You can do a lot with this one, but for this tutorial, let's just go ahead and look something else. So you can write also into this file. You can also write multiple lines. You can also count word occurrences, or maybe um, check if the file contains specific numbers. You can clean up the file, you can handle missing numbers, you can do a lot of things, but basically that's how you handle files. You can put them, you can manipulate them. Let's say I have a file that is, okay, I can pull this other file and manipulate it and do analysis with it. I have a video already for file handling, so you can, if you want further details, you can go back and take a look at that one. Thank you. Let's move on to the other section of the course. Let's quickly talk about modules and libraries in Python. So if you were following along in the tutorial where we discussed about functions, we were typically writing our own functions to do specific things for us. But Python, you have a large community and a large ecosystem of modules. So some of the modules or some of the functions, you don't have to write them. They are already written for you. All you just need to import them to your code and use them accordingly. There's also a video tutorial that I've done already where you can just create your own modules so that you can import them and work with them. But let's use pre-built modules. Here's our standard syntax. So if you want to import your module name, or you can, this one imports the whole module name, or you can import a specific function from that module. So the syntax will be from your module name, import a specific function. So that's the basic syntax here, and we'll be using that. All right, so one of the most popular module that you might be using is math, the math module. So you can say print math dot square root of any number. Let's say 16 here. When I print it, it's going to give me the answer. Now, square root is a function that's already pre-built for you, so you don't have to type and calculate how the square root is going to operate. You just have to import the module and work with it. Now, you can also, this is the whole, I'm importing the whole module, and I can import a specific function. Let's say from math, import square root, print of 16. Okay, yeah. From math, import square root, then it will just work for you. So another thing is that usually we do not want to, we want to summarize our codes. We want it to be very clean and readable. So we can use aliases. So we can say import math as m, then print m dot square root, whatever number. All right. There are also built-in libraries that are there. That will be an exercise. Go to python.org and see what libraries are out there. For example, we have libraries like Beautiful Soup. Just go take a look at that and see what libraries you can have. So there's also this important one, which is called datetime. So again, from datetime, import datetime. So there's this method called now is equals to now. There is a video that I have done already that specifies how to do with time in Python. But let's move on, and this one will give you the exact time and date that we are having. All right. There's a video that I've dedicated, I think is about 15 minutes long, that deals with this date time module in detail. Let's move on to the other section. So look at third-party modules, try to find one or two, play around with it, and see what you can derive from it. So that is that for modules and libraries for this section. Let's go ahead to the next section. everyone, in this video I am going to explain how to handle exceptions in Python. For those who know, we have two main categories of exceptions in Python. We have got base exceptions and we also have concrete exceptions. For base exceptions, we are looking at buffer errors, arithmetic errors, lookup errors, and for concrete exceptions, we have a ton of them, including name error, type error, index error, key error, zero division error, index error, and many others. And also, I think I should add on this list, we have got our warnings that we have in Python. But anyway, let's go back to exceptions, what they are, and how we can bulletproof our code so that we can prevent those errors. So we can prevent our code to stop running and it will keep on running whenever we encounter possible or potential errors. All right. So I want you to notice that I want you to notice that um, whenever you run your code in Python, it will exit at code zero. Let me just comment this one out. Right. Run everything again. Now it will exit at code zero. Anything that is not code zero, it will be one, and that will be an error. Python will show you the error and you have to rectify it. All right. So right now I want to show you what name error is. And in Python, remember, you do not call a variable unless you declare it first. So right now I haven't declared first name and I'm just asking Python to print it. And when I print it, I have a name error and I exited code one. What does it say? First name is not defined. So I need now to define what first name is before I call it or before I print it. First name is equals to John. So now when I print this, I'll exit at code zero and I won't have any error. So you have, if you do not declare a variable and you try to call it, you are going to raise a name error. All right, I'm going to comment everything out. Let's go to the second one, type error. Now, in Python, there are many data types. We have strings, we have integers, we have floats, we have sequence such as list, tuples, and range. We have dictionaries, sets, booleans, binary, and non-types, just to mention a few. So right now, I have got two types of data in my print statement here. I have an integer, which is 2, and I have another 2, which is in quotation marks, which means it's a string. So if I add this one, 2 string plus 2 integer, I am going to raise a type error. Type error, you are trying to concatenate string to an integer. So exited code zero. So to fix this one, I have to make sure that I have the correct data types, or yeah, correct data types before I do my any manipulation whatsoever. But I want you to notice that if I multiply it by 2, I'm just multiplying a string by 2. So I'm not going to have an error because this 22 is just a string. Just like if I say, all right, and run it, you're going to multiply it by 2 because it's a string. All right, I'm going to comment this one out. Index error. Let's say I have my list here with 3 items, 11 on index 0. Let me put it this way. So 11 is on index 0, 32 is on index 1, and 39 is on index 2. Right. So I don't have anything beyond index 2. And if I call, let's say in this example, index 0, I'm going to print 11 to my terminal. I'm going to print 11 because 11 is on index 0. But if I print item on index 4, I am going to raise an index error because the list index is out of range. Exit code 1. So if you call an index on a list that is out of range, you're going to raise that index error. All right, commenting this one out. So there's also a key error. Now, suppose you have a dictionary like this dictionary, and I call something that is not with in the dictionary. Let's say, for example, I say I call height. Height is not in the dictionary. It's not a key in the dictionary. We have got three keys only. We have name, age, and education, and height is not in the dictionary. So if I print it out, I am going to have a key error, and it means that I don't have that key in the dictionary. But if I call, let's say, age is within the dictionary, and it's gonna exit code zero, no issues. Right. Last one that I want to showcase is the zero division error. The zero division error happens when we try to divide an integer or a number with zero. Right now, I have age, and I'm asking the user to input their age and transfer that age or cast it into an integer. And then I put another income variable here, which is 10,000, and I want it to be divided by age. And let's see how this code works. So enter age, the user will enter 50, and it will 10,000 divided by 50 to give me 200. But now let's say the user enters 0. I'll get a zero division error, exit code 1. You are divided by 0. Simple arithmetic, we cannot divide by 0. So how do we handle these errors or exceptions? We use the try block. So I'm going to show you how the try block works. So try, then you have to indent this one. Right, except, use the except. Except the zero division error. I want you to print age cannot be 0. Right, if I run this code now and if the user enters 0 on age, it will keep on running. It will not break the code, but it will run and it will exit successfully. So I'm going to run age, they'll enter 0, and when I run, it exits code 0, and it will tell them that the age cannot be 0. Now, you can also take the print statement out of this and use the else. So else print income, just the same. When you can, let's say you have all the errors that you want to list, you can add all the errors here. Then else, if there's no error, it will print anything else after you handle the errors. So right now, if I say age 0, it says age cannot be 0. But if they give me the correct age, like 50, they need to print. So you can add all the errors that you handle that you can expect in your code, so that you will like kind of bulletproof your code for any errors. That's what you do as a seasoned programmer. Thank you and bye bye. Hello everyone. In this video, I am going to discuss with you object-oriented programming. Now, this is a very, very important topic when it comes to programming, because with object-oriented programming, we are able to not only have our code versatile, but it's easy to manage, and also it can be applied to real world problems. There are, I would say, four main concepts of object-oriented programming, which are abstraction, encapsulation, polymorphism, and inheritance. But before we get to that, I want you to know that there are two main key concepts, which is class and objects. Now, class, think of it as a design, and object, think of it as an instance of that design. For example, I have a laptop right here that I'm using. Now, all laptops out there in the world, they share the same design, but each laptop is unique. This laptop can be an i7, another laptop can be an i3 or i5, and they may have a different RAM, different memory. So think of it as like cars. They all have the general design, which is the general properties, but each car is unique. So let's jump into our code and have a practical example on how you do your projects using OOP. For our example, I'm going to use a car garage as for an example. So now I want you to know that a class we said is a design. It have got one item, it actually have got two items. It have got properties, which are some other people call them attributes, and also it have got methods, which some other people just refer them as functions. We said a class is a blueprint or a general design. Then objects are instance of a class, are instance of a design. We're gonna do this, and we're gonna look at the code and explain this concept in more practical way. Let's go to the code and start coding and see. All right, so we have our vehicle here. So by convention, when you are defining a class, it has to start with a capital letter V. Remember, when we are doing variables, it by design they have to be a small letter name. So, but for classes, it has to be capital letters or capitalized. All right. So let's initialize our class. All right. So each car has got a brand. In our case, for in this example, let's just have a default brand name which is unknown. A model equals to unknown. Year equals 0. This is just right. Oh my God, I can't type. It's a Friday here. All right. So these are our attributes. So each car has got a brand, a model, and a year. These are our attributes. Now let's go on and also give a method to this. So our first method is to describe these cars. So a method, we said another name of a method is a function. So I would say description here. I just want to return the description of this car. Software, brand, and model. All right, so our first method is just to describe this car. Now, another concept is to inheritance, right? So each car, though they are unique, they inherit the same they inherit the same properties like brand, like model, like here. So let's do class here, car. So they inherit the properties in the vehicle. All right. I want to initialize them. Actually, I need brand. We want to take the properties from the vehicle, brand, model, I would say year, color, fuel type. In our case, let's just say unknown. I'll come back to this one. Brand, model, year, then which are unique to this particular car is color and fuel type. Now I'm going to initialize, or let me just do it this way. All right, looks good. When taking this from the vehicle class, and also now our additional car attributes. Self.color equals color. Self dot looks good. All right. So we're gonna create the another method to define this color, this car. Okay, some space here. I would say car info. On this one, I just want to return the description and the specific attributes to this specific car. So I'm going to do this. We need description to take the attributes from the to the main class here, base class here. So I'll do description. It should be self and fuel type. This looks good to me. All right. So now we have identified our base class, and now we have our own individual attributes of cars. Let's go ahead and create the instance. So our car number one. So we want our car to be maybe a Toyota, a Highlander, maybe let's say 2024 year model, and fuel type. Let's say it runs on gas. Let me have another car number two here. It have got the attributes from car and also its brand. Let's say it's a Tesla. Right, a Tesla, a Model S, This color is red and fuel type is electric. All right, looks good. So electric, good. So now we want to access these methods from both the car and the vehicle classes. So let's do this. Let's print car, let's say number one, and you want to see its description. So if I run this one, you will see that, okay, let's just look at it. Missing one required positional argument color. All right. I'm missing color on car number one. Yeah, yeah, yeah. That's why this color equals white. All right, looks good. Okay, let me do it this way. All right, okay, I see this issue. All right, so let's go ahead and run car description. We can see that for car number one, um, it went back to take the general attributes right here from the base class, and also the specific for the car, that particular car, the specific for that car. So we can do the same thing if we, alrighty, if you print the car number one dot info, now it will give us the specific information for that car. And we can also do this. We are accessing those methods now. So let's say let's do car number two. The car info. It's gonna tell me the details of the car number two. And we can also do print car two description. It will tell us the, the general description from the base class. So in this code, we have also discussed the four concepts of object-oriented programming, which is your abstraction, encapsulation, inheritance, and polymorphism. Inheritance, we see that car inherits from the vehicle, and polymorphism is though we are doing car.info here, info is behaving differently for an electric car and a gasoline car. So I, it changes, or it changes depending on the object we are calling. So that is basically your. So I kept on iterating on this project, and yeah, I have, here's my final product for the day. All right, so we still have our own base class with the description, brand, model in here, and the description here. These are our basic properties and our description to describe the car that we have. And we inherited the attributes from vehicle to car. And also now we have car info, start engine, stop engine, drive car, check fuel, refuel, reset trip, all this method that I've added: brake, accelerate, honk, change color. So these are the two instances that I've created. I will just create another one, a third instance. Alrighty. So I'll call this one car number 3. And this car will be a, let me say, a Benz GLE 500. It's a 2024 model. It runs on gasoline. I will keep everything as it is. All right. So let's test the functionality of this code and see what we have. So right now on the terminal, we have nothing. And let's check, for example, let's go with car number 3. Let's start this car. So the engine has started and let's drive it. Drive car. Let's see the result. It's driving. So now, whilst I'm doing this, you can imagine it can be a building block for building a game. So we can now check the fuel level is 40 units. Cut 3. Short trip distance. I've used I have used 10 units of fuel. All right, let me just do something like car 3 accelerate. Yes, I'm missing a positional argument because I have to, if you look here, I have to determine the level of increase. So if I say car 330 and run it, accelerate 30 kilometers an hour, we can brake, reduce the speed. Car number 3, I'm gonna brake with maybe 10 kilometers an hour. So we are now down to 20 kilometers an hour. And we can go and on using this method to test this code. So this was just to show you what you can do. I'm going to supply this code in my GitHub, and you can take it from there and build from it to whatever you want. Let's see if you can add some more functionality to this code. Thank you for watching, and bye bye.